Welcome to our channel, my dear students. Today we are going to talk about the previous year, that is last 10 years CBSE board chemistry questions part 16, in which we are going to discuss alcohols, phenols and ethers. The question number 1 is, write the main product in the following reaction. This was asked in the year of 2016. So the question is, on 3-degree ether is taken and that is attached with HI. If hydrogen iodide, nothing but the protonation reaction, what happened? So here this will be acting as protonation. By that way, it will be giving CH3, CH3, again CH3. So here it is I. It forms 3-degree carbocation along with CH3OH. So on 3-degree carbocation is formed, the I minus, this is H plus and I minus. This I minus will come and attack the 3-degree carbocation, and the H plus will go and attach with this CH3O group and to form alcohol as a product. Are you able to understand? Here iodine is an exceptional case where the higher number of carbon is existing. That place the iodine will go and attach, but usually in ethers negative entity will go and approach the least number of hydrogen atoms, least number of carbon atoms. Next one is, write the following with examples. This was asked in the so many years, 2009, 10, 12, 13, 14, so many years this question was asked. Williamson ether synthesis. Usually the Williamson ether synthesis method can be used for the preparation of or synthesis of unsymmetrical ether. So unsymmetrical ethers in the sense, so we have to take two different type of reactant. So here I have to take 3-degree alkoxide along with 1-degree alkyl halide. What I'm going to take, so 3-degree alkoxide, this is 3-degree alkoxide along with 1-degree alkyl halide. Now the product will be getting like this. So what kind of product I will be getting? So here is nothing but CH3, CH3, again CH3, here it is O, CH3 along with NaBr I am getting. Suppose instead of that, if we are taking this as a 3-degree, this is a 1-degree, you will be getting alkene as a product. So choosing of a reagent is very important. So here in this case, so if you are taking 3-degree alkoxide, sodium alkoxide, it's a sodium alkoxide. If you are taking sodium alkoxide 3-degree and 1-degree alkyl halide, at that time you will be getting ether as a product. But in the same time, if suppose vice versa, suppose if you are taking 1-degree alkoxide and 3-degree alkyl halide, why it is so? If you are using 1-degree alkoxide, say for example CH3ONA, so this will not be acting as a nucleophile because this will be acting as a strong base. This is a conjugate base. This conjugate base will always attack hydrogen. That is what it picks the hydrogen from the reactant. So it forms alkene as the product. So our ultimate product is alkene. Are you able to understand, student? Okay. And next one is, explain the Friedel-Crafts acylation with an example of an ether with an example. Friedel-Crafts acylation. Usually in the case of Friedel-Crafts, so I am going to take an ether. So here methoxybenzene I will be taking. So if it is react with acylated product, what kind of acylated product? So I can use CH3 C double band O Cl. But in this case, which is not required in the sense, even we can use an ethanoic acid. Ethanoic acid is enough. So we no need of any catalyst because this OCH3 group, it's a highly deactivating group. That is what the deactivation power is so much. So electron density, which will keep the electron density on ortho and para position is much. That is what which one is not needed. So catalyst is not needed. So without catalyst, this reaction may happen on its own. Now what will be the product? So I will be getting the product like this. So here it is OCH3 along with that C double band O CH3. This is nothing but acylation or acylation. If you don't know about the mechanism of this, please go and watch my previous video. You will be getting good idea about this. The next question is, account the following. The boiling point of ethers are lower than their isomeric alcohols. This question was asked in the year of 2011. Boiling point of ethers are lower than their isomeric alcohols. Suppose if I am taking ether, CH3O, CH3. What is isomeric alcohol of this? CH3, CH2, OH. Why these are all isomeric isomers? Because these are all functional isomers. Because here C2H6O. Here also C2H6O. So both are having same molecular formula, but the structural formula is different. That is why they will be acting as a isomers. Here, due to hydrogen bonding, here it is a hydrogen bond is there. Alcohols will be taking place involving in the reaction with water or any other oxygen, nitrogen, fluorine. So highly electronegative atoms. That time it forms a hydrogen bonding. So that the hydrogen bond will be very strong one. So we need to break this bond. We need to supply more amount of energy. But that is what the boiling point may also increases. But in the case of ether, it has only dipole-dipole interaction. So dipole-dipole interaction only is there. That is what it has very less boiling point when compared to what is that alcohols. So here alcohols are having much more boiling point. This is due to hydrogen bonding. If you don't know about the hydrogen bonding, please go and watch my previous video. Then you will get idea about this. And phenyl methyl ether reacts with HI to give phenol and methyl iodide, and not iodobenzene and methyl alcohol. Why? So this question is asked in the year of 2010. This is very important question. So as we know that phenyl methyl ether, now we have to write the structure. This is nothing but the phenyl methyl ether. This is phenyl and this is methyl ether. So there is nothing but a methoxybenzene or anisole, whatever it may be. So you can name it. So it reacts with the HI. So it reacts with the HI. Now what happened? This will be positive charge, this will be negative charge. Now, so oxygen having lone pair of electrons. So donate to H plus to get a product like this. So I will be getting an ion like this. This O. Here also H and CH3. Here I will be taking a plus. Okay. Are you able to understand? Now, the I minus will come and attack. So, as we compare to, this will be taking if suppose this hydrogen leaves, what happened? This will be forming a bond. This CH3OH will form. Now, if protonation, this will be giving the strong bond between this C6H5O. So this C6H5O will be there because the partial double bond is getting created. Now, that is what this bond will be very strong. So this bond will be very strong. But I minus approaches. So now what happened? Now this bond is getting, it is very weak. This is very weak. So this bond is getting breaked out. So this bond in the sense CH3OH, that alcohol will goes off and I'll be getting, so this CH3I will goes off. That is CH3I, methyl iodide. This bond is getting break. This will be very weak. So I minus will come on approach, and if bond is getting break, what happen? Now this will be goes off a positive charge, and I minus will be there. So it will be formed as methyl iodide. So when positive negative charge is there, that negative charge can be utilized. So that is what I will be getting phenol as a product. Are able to understand, student? So this is very important question. So as we know that, so here I'll repeat once again. So here methoxybenzene will be taking, HI is there. So if it is protonated, I'll be getting a structure like this. So in this, so it will be getting a partial double bond character. That is what, moreover, it will be a very strong one, C6H5 and O. This will be getting a very strong one, strong bond. But in the case of CH3, it will be a weak one. So CH3I will be getting formed and phenol is getting formed. So instead of that, if I am not getting iodobenzene and methyl alcohol, I will be getting phenol and methyl iodide as a product. Are you able to understand, student? Thank you so much for watching. Please go forward to others to get benefit. Thank you so much for watching. Please subscribe my channel. Thank you.